Everyone, welcome to the channel. Please like and subscribe and follow me on Twitter if you want to get the latest updates on new content. Without further ado, let's start and learn something epic. So today's problem, we'll be looking at validate binary search tree. Here's a little definition of the binary search tree. It says that the left subtree of a node contains only nodes with keys less than the node's key. The right subtree of a node contains only nodes with keys greater than the node's key. And both the left and right subtrees must also be binary search trees. What we know here is that we can traverse the tree with a tree traversal. And as we traverse the tree, we can check that these conditions are true. So we see that whenever we traverse to the left, those values have to be smaller than the root. So when we make this recursive call to the left, we say that the maximum value of the left subtree must be less than or equal to 2. And whenever we make a recursive call to the right subtree, we make sure that the minimum value is always greater than or equal to the root value. Breaking down the problem into cases, we know that if our node is none, we know that this is true because the null value will satisfy the condition. Empty node is true. And then if we know that we don't have an empty node, we'll check that the maximum and minimum conditions are satisfied. Lastly, we make our recursive call, which will traverse the tree. Now for this function, we just have a root without the ranges, so we could use a helper function. The first two values, two nones, those are the minimum and maximum values that the current root can have. So initially, the root can be anything, so we'll make those values set to none. Now we'll define the helper function. Like I said before, the first two will be minimum and maximum, and then lastly, we'll have our node. So our base case that we wrote in the bottom can move it up here, make it a little bit nicer to look on the eyes, or easier on the eyes. And let's see. Okay, if the node equals none, if it's empty, return true. Check the maximum conditions are satisfied. So maximum, if the maximum is not equal to none and maximum greater than equal to our node's value, okay, yeah. Or sorry, that's not maximum, it's supposed to be minimum. If our minimum value is greater than or equal to the current node, then we'll return false. And then similarly, sorry, this should be minimum. Maximum not equal to none, meaning we have found our maximum, and maximum less than or equal to node dot value. Then we'll return false. Now we make our recursive call. So when we call the left, we'll make sure when you call the left, you have to make sure the maximum is the current root value. So we pass in the same minimum, and then the maximum is updated. And we're traversing left. And you have to make sure that the right subtree is also equal. And this time, the minimum has to be at least greater than the node. So we update our minimum and then we pass in the same maximum. We're traversing to the right. Let's check our code with our test cases to make sure that the code works. See if we can copy and paste this down there. Oh, awesome, awesome. It works. Okay, so if we follow our code, we call self.validHelper first with none none on 2, and then 2 is not none. So we move on to here. Also, minimum and maximum have not been assigned, so we'll call left. And as it calls left, it makes sure that the minimum is now, the maximum is now 2. So we go to 1, and for 1, it is not as null. So then we go to the next condition, and then we see that maximum has been assigned, and it's been assigned to 2. Maximum, however, is not less than or equal to 1, so it does not return false. Then we do a recursive call to left, and then that will yield none, so we return true. So left call for 1 is true. Then the right call for 1, it will also be true because the node is empty. So now 1 returns true. Then for 2's left call, we're done. It returns true. And then the 2's call to the right, it'll assign the minimum, which is 2. Well, assign the minimum as 2. So now we traverse to 3, and when we're on the third node, we see that the node is not none, so we continue. And then we see that the minimum has been assigned to 2. And 2 is, yes, the minimum is assigned, and the minimum is not greater than or equal to 3. So we continue. Then on 3, we make a left and right call, and both of them are none, similarly to 1. So 3 returns true. And then lastly, 2 will receive its right call, which is true, and the left call was also true. So in the end, this output is true. You see here, bam, it's true. Okay, now we check our second test case. For our second test case, we know similarly to before, 5 calls 1 and then 1 calls none. We know that these leaves, they're always return true. So left call for 5 will be true. 5 will call 4, and it will make the, when you traverse to the right, you make the minimum equal to 5. And then 4 is not an unknown, so we do not check this condition. So now we see that the minimum has been assigned, and we see the minimum is greater than or equal to the node value 4, so we return false. So the right return of 5 is false, true and false is false, so we return false. And then we check up here for the test, bam, it's false. So that concludes these 2 test cases. Now let's check just to make sure all the variables are lined up. So is valid bst self root self.valid helper none.root. We have 3 arguments here, and we also have self valid helper. All right, that looks good. Base case node equals none. Node's right here, and then minimum node.val maximum max.val. 2 recursive calls, 1 call to the left. When you go left, you have to change the maximum, sorry. And then when you traverse the right, you change the minimum. Okay, let's do the submitto. Judging, accepted, alright. Looks good. Oh, must be our comments. Let's, is it our comments? Alright, let's do, I think it's kind of slow because of the comments. Let's see if that's true. One moment. Huh. Okay. That's interesting. I was confused why our code is so slow, but I took a look at some past submissions, and I realized that, or not realized, but I learned that having spaces actually makes your code a lot slower. I guess that makes sense on a very maybe low level code. I'm not sure. You know what? Leave a comment down below why you think maybe having spaces makes the code run a lot slower. Is it because it has to go through an empty space before it receives the next instruction? Perhaps that is, but let's check it out. Let's see if it actually makes it better. I think it does. Let's see. Alright, submitted. Okay, 73, that's okay. I suppose the server may have something to do with it. I got it to 95 at one point, but actually, I'm not sure why that would cause that. Yeah, just please leave your theories in the comments below as I ponder this. Anyways, I hope you guys enjoyed solving this problem as much as I did, and I hope you learned something. Please like and subscribe for more content, and follow me on Twitter for latest updates. Thanks so much. Have a great day, and happy learning, and enjoy the rest of the day.